Hello, in this video I am going to go over the homework 3.1. For number 1, the graph. Here is the graph, and then from the graph they want you to find the area from 0 to each number, such as when it's from 0 to 1. So your area should be this part, right? So when x equals to 1, so the area from 0 to 1, the highlighted part, should equal to 1 times 1 because it's a square. And the next one is from 0 to 2. It contains 2 square, so this part is easy. So I have 1 times 1 times 2, because we have a 2 little square at the little triangle area on the top, or half of the square, either way. So you should add half of the square, which is 1. Each cubed is equal to 1. So I have 2 plus 1 half. You can write it 5 half or 2.5. So similar, you can do from 1 to 4. This is not hard. Let's do another one. So from 3, I don't think it's hard. Let's do the whole one from 5. So from 5, the first thing we can take a look how many square they have. In the bottom, they're all square, right? I got 1 square, 2nd square, 3rd, 4, 5, and even this one is a square. So you totally having 6 square. And then the next thing is, take a look the area that is not shaded, which is the 2 red part now. It's 2 triangle. When they're combining together, this has become a full square. So totally we have a 7 square. So the total area from 0 to 5, meaning that when x equals to 5, the area equals to 7. And you can calculate that by yourself. Number 2 is similar to number 1, so I am going to skip him here. Now let's do number 3. I'm going to pause and draw the graph. Alright, so the area from, let's just do 1. They want you to find the area from 1 to 3. Let's just do 3. So when x equals to 3, your area is going to be this part, the highlighted yellow part. So this is a trapezoid, if you notice that, and then the area of a trapezoid is equals to the top at the bottom length over 2 times the height. Okay, so I can consider this part is the top, which is 1, and the bottom is this guy is equal to 3, and the height is 2. So the area should be 1 plus 3 over 2 times the height, which is 4 units. And how do we find the area? So the area is, we can use the integral formula to represent the area. In order to get the integral area, we need to know this one is bounded by what? This one is bounded by the red graph, which this is a linear graph. This graph is equal to, the slope is equal to 1, and the y-intercept is 1, so it should be x plus 1. So the area is equal to, from 0, because it's bounded by y-axis, to x, could be up to 3, 4, 5, 6, 7, 8, 9, 10, because they didn't give you a stop, a range. dx. So that's the area, that's the function to represent the area of the graph. Okay, now next question. Number 4 and number 3 is similar, so I'm not going to go over number 4. Number 5. I know, this is number 5. Number 5 says that a car has a velocity shown in the graph. And then they ask you how far did the car travel from 0 to after 13 seconds. So we know that the distance is equal to the velocity times the time, which in our case would be the y-axis times the x-axis, and then the equivalent to h times length. Basically, height times length or width times length, this is a rectangle. We're trying to find the area of the graph. Then we will have the distance. Now, the area, we can look them into two parts. One is the rectangle part from 0 to 20 seconds. So I have a rectangle, which is the bottom times the height, which is times 13, add a little small triangle, which is half of the bottom, which is 13 minus 20 gives you a 10 times the height. So I have 600 plus 150. So the total travel distance is 750 feet. Okay, here is number 7, and number 7 asks you from what time the brake started and where did you hit the brake, and then when does the car completely stop. From the graph you may see a black dot. So in here you might be able to see that at that point, when equals to 20 seconds, let's look at the graph A. When at 20 seconds, that is still have a turning point, and then the velocity was 80, 80, 80 until 20, and then the velocity is decreasing. So that means at the time equals to 20 seconds, the brake starts. And then when does the car completely stop? For A, for the red line A, when the velocity equals to 0, the car stops. So that means at t equals to 14 seconds, the car stops. So this is similar to B. For B, the blue line, at the time t equals to 20. Let me see if my graph is correct. Let me double check my graph very quick. Yeah. So at the time t equals to 20, the blue line, in the blue line, the brake will apply. Because after that, the velocity decreasing. And then at the t equals to 60, the car completely stop. Okay. Next one is from what time the brake will apply, which car travel further when to the complete stop. Okay, so now we want to know which car travel further after it stop. So we can find the area after the brake apply. So for A, the area is going to be the red highlighted part. So the distance for car A traveled after hit the brake is what? The area, which is 1/2 80 times 20, which is 800. And then the distance B traveled after hit the brake, it's going to be the blue part, which is also from 20 to 60, but the height is different. It's going to be 1/2 40 times 40, also 800. So they travel the same distance after they hit the brake. Number 8 is quite similar. I'm going to link that to you. Okay, number 9 is a police chase application problem. So the speeder travel 40 miles per hour, so definitely the blue line, because you can see that his starting speed is 45 miles per hour and it's maintained the same speed. So this is the speeder's graph and this one is the police car. And the police car starting speed up like from 0 to 60, because if you're trying to chase someone that before you need to drive faster. But there's a time to accelerate the speed. So that's why the speed is from 10 seconds, it's speed up from 0 to 60. And then how long and how far before the police car catches the speeder who continue to travel 45 miles per hour. So you think about when you catches them, that means your distance are the same. Well, for the speeder, the distance is very easy to calculate. Let's set the time x, let x be the time the police and the speeder catches the speeder, caught the speeder. So that means for the speeder's distance, should equals to the police distance, which is the area, should be equal. So the speeder distance is equals to 45 times x. So the police car is a little bit complicated because it contains 2 parts. One part is a little triangle because they might catch up in the front, but it doesn't look like it. So the first part would be 10 times the height, which is 60. Triangle is 1/2 the bottom times the height. That's the triangle. And then this part, we don't know how far did it go, so that's why it's x. But remember that your travel time should minus 10 because the first 10 seconds we already use it and apply in the little triangle. So when you're calculating the area, you need to minus the 10 because it's starting from the 10 second. So that's why we have the time minus 10 second times 60. So then we solve it. We have a 45 x equals to 300 plus 60x minus 600, and then we solve for x. So I got 300 equals to 15x, and then x is equal to 20 seconds. So that means at t equals 20 seconds, the police car catches the speeder's car. But that's the time, because they ask you how long and how far. How far means we still need to find the distance, how long did they travel. So we already know the time, so we can either use the speeder's formula to calculate the distance or the police car. Either way works because they travel the same distance. I would use the speeder because it's easier to calculate. Just use the time times the speed, gives you 900. So after 900 feet, they catch each other. So here's the graph. They want you to estimate how far did the car travel in the 20 minutes. Usually I would draw a graph a graph which shows you what does that look like. So at 0, time I have 5, 10, 15, 20, and for speed I have 40, 60, and then 0, and then at 5 my traveling time is here, starting from 0 to here, and then the next one is going to be 10 and then 40, it will be here, and 15 to 65, this part, and then 20 to 40 will be here. So this is the travel graph look like. The way I do it is I found the area and cut it into different pieces. For example, the first part is a triangle, and then I have a square or trapezoid, whatever that you feel like you want to cut it or serve it into different geometry, or maybe a little square or little rectangle at a triangle that also work, or trapezoid. And then on the top could be another triangle at a rectangle, which is this part. Either way that you can find the area. So starting with drawing a graph. So that's the hint for number 11. Number 12 is similar to number 11, so I'm going to skip that. Now number 18. Number 18 is use the graph F shown the given area of the several region and estimate. So from the graph, we have two parts, the part that above x-axis and the part that below x-axis. And we know that this area is equal to 5, and this part's area equals to 3, and this part of area equals to 2. Yes, 3, 5, 7, and they want you to integral from the graph from 0 to 3. We got what? From 0 to 3, the area should equal to 5, so that's the integral. Part B is from 3 to 5. From 3 to 5 is equal to 3, and then from 5 to 7 is 2. Basically, the integral from which area, from x, is the area of that part. So number 19 is similar, so I'm going to skip that. And then the next one is number 27 and 28. 27 and 28. Number 27 says that the region bounded by, so the region was bounded by y equals to x cubed, and the 9 x equals to 1, and then x equals to 5. So here is you're trying to find the integral from x equals to 1 to x equals to 5, and bounded by x cubed dx. So that's the area, and finding the integral.